Welcome back. The objectives of this video is to introduce the natural base value e. We'll evaluate e using the calculator, and then we'll sketch some graphs of base e. But first of all, what is e? Well, e is a fundamental number in our universe. It's a little bit like pi. It's an irrational number of approximately 2.71828, etc. It's named in honor of Leonhard Euler. It's considered Euler's number. It's not Euler's constant. It's also known as Napier's constant. And it's used often in calculus, engineering, and compound interest and other applications. So it does show up in nature and other places. And so we'll do quite a bit of work with e throughout the year. Our second objective here is to use our calculator to evaluate each function at the indicated value of x. So we're going to use our calculator and figure out what these values of e are to a particular power. So we'll start. The e key here is the blue key. It's above the natural log key. We may have seen that in a previous video. We want to find e to the x when x is pi. So e raised to the pi power. So it already gave us the exponent here and second pi. So I've got e to the pi. So e to the 3.1415, blah, 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 blah. And we get 23.14. E to the 1/2. So second e to the 1/2. You could do 0.5 as well. And we'll just do 1/2. 1 divided by 2. E to the negative 2.5. E all raised to the negative 2.5. or negative 5/2. And we get a small number there, quite the fraction. Well, it's a negative exponent, so that's going to be a fraction. And then, again, e to the 6.2. We don't really need the parentheses here. And 492. So a few easy problems just finding e raised to a particular exponent. And moving on to our third objective, in the same coordinate plane and using a table of values, sketch the graphs. So we have two different graphs here. F of x equals 2 times e to the 0.24x. So our unknown is up in the exponent here. So I did our table of values, and I put 0 in for x, and 0 times 0.24 is just 0. So we have e to the 0 power, which is 1. So this really became 2 times 1, which is just 2. And then I put 1 in. And now for the rest of these, to figure this out, I had to use my calculator, just like we did in Objective 2. So I had to get those values in, and I plotted those points over here on the coordinate plane. And then I did the same thing with g of x, where we have 1/2 e, but this is to the negative 0.58x. So that is going to be somewhat of a reflection over the y-axis. It's a different function, but it's going to also move in a different direction. With that negative exponent, we're going to fall as we move from left to right, whereas when we have the positive exponent, we rise when we move from left to right. So again, I chose a bunch of values for x, and I put them in, and I used my calculator and got those particular values, and I plotted those points. Another way to do this is you could just put the values into your graphing calculator. So if you take a look here, I have, prior to the video, I put the equations into my graphing calculator, and I plotted them both. So the 2 to the 0.24x was in blue, and the red is the 1/2 negative 0.58x, and sure enough, I got graphs that look a little bit like my sketch. So here's A, and B is in red. And you'll also see here on the screen a table of values. So you can see the values for 0, 1, 2, -1 for the blue function and for the red function. Now that came up automatically on my screen, but you can also go to the table function on your graphing calculator. We can just hit second table and that table will show up, and we can scroll up and down the table to get the values for that. So that's a handy thing. You can use your calculator for that. That'll calculate those values right on the graph, your ordered pairs x and y for each of those two functions. So that should be helpful for you guys as well. So that concludes our introduction to the natural base E, and we'll work more on this when I see you in class.